this lesson, we're going to look at the transformation of some trig functions. In this case, you are only going to look at the horizontal compression. For instance, if I were to press this, that's compression. Or we'll look at the horizontal stretch when it be like pulling like that. Okay, so let's look at some of the examples. So let's look at this graph. This is a sine graph. Y is equal to sine theta. As we know that the period of this graph is 360 degrees. Let me write 360 degrees. So when we are compressing this graph, it means that we will hold here and then we'll push here so that it's compressed. Similarly with this one, the period is 360 as it is standard form, but we are going to compress it and we'll hold this here and then we'll compress it. So how do you do that? Let's look at this example. It says y is equal to sine 2 theta. So we've got to compress this graph so that we get the graph y is equal to sine 2 theta. So what do we do? To get an answer, you just take the period of the original graph, which is 360 degrees, you divide it by the 2, which means that you get 180. 360 divided by 2 gives you 180 degrees. So when we compress this graph, we'll end up at 180. So we'll end up here. So I need to draw a graph like this, but to end up here. So which means that my graph now, so this point would be at 90, so it would be at 90 there. So it means that my graph will go up high and then does this and turn just like that. So I've got the same shape as that graph, but it has been like compressed. Now the period of this one, the complete wave, was 360 degrees. Now this is a complete wave. Now what's the period? The period is equal to 180 degrees. So to get a period of the graph, you'll take the original graph, you divide it by that value which is given there. In this case it's 2, so the period is 180 degrees. So I've got that. Now let's look at this one. So this one, the period is 360. Now if I divide it by 3, I would get 120 degrees, which means that if I push this, it will go up to 120 degrees. So I think 120 degrees will be somewhere over there. So I'll have a 120 degrees over there. So I'll have to draw something like this in this space. So I think I will have something like this. So which means that my graph will do something like this and a 10 there, and then I've got it like that. So I've got it. So that's what it means. One other way of looking at this is if I were to draw the graph y equals to sine 2 theta, it means that in the 360 degrees I must be able to fit in 2 sine graphs. So if that is the first one, I can fit another graph here. It's exactly the same as that. So which means that the graph will do this and then do that, and there we go. So in the 360, to see I've fitted 2 of the sine graphs. They're just there. But the length or the period of one graph is 180 degrees. So here, that's y is equal to cos of 3 theta. It means that in this, I must be able to fit in 3 of these things here. So which means if I were to do this, I could put something like that, and then it will go like this, and then so the third one will fit in here, and then we'll do something like this. You can see that I've fitted 3 of the same thing. So the period of this complete cosine graph is no longer 360 degrees, but how long is it? It goes up to 120 degrees, or say 360 degrees divided by 3, which is equal to 120 degrees. That was about compression. But another one that we spoke about, we said we spoke about stretch. So when we are stretching now, so it means that we must stretch it. So I'm holding here, I'm pulling it like that. So if I'm pulling it like that, so where will the graph, complete graph, stop? Or what would be the period? First, let's look at the period of this one. Period, we know the standard one is 360 degrees. So which means that the period of the graph that you are going to do now, the new one, will be 360 degrees divided by 3 over 2, which gives us the good answer, which is, here's a calculator, is 360 divided by 3 over 2, so I'm dividing by 3 over 2, I get 240, so which means that the complete graph that I will draw here will end up at 240 degrees. 240 degrees, that is 180, so 240 will be somewhere over there. So I'll have to complete and draw this graph like this to end up at 240 degrees. Okay, let's see. So to end up at 240 degrees, so it means that one part would be this, so it means that I'll draw something like this, going up there, and then I've got there. So that goes to 240 degrees, 240 degrees, so it means that this is 120 degrees. So obviously if you wanted to complete this to 360, you won't get the same size as this, but the period of this one is 240 degrees. The next piece that you are left with, if you wanted to complete the thing up to 360 degrees, you can only have one part of the graph. There is no longer like the full thing, but the complete graph will be there. So what did you fit in here is 3 over 2 of the thing. So it's this 3 over 2 parts that you've got here, 1.5 parts is 1.5, because 3 over 2 is 1.5, so we've got 1.5 parts of these things in here. Note that sometimes they don't say start a graph from here to 360. They can also say you should have started on the negative side as well, so we can continue drawing the graph like this, like the examples that you'll have to draw. You'll have the negative parts. This one makes it easier for you to understand. We can also do the same thing with the tan graph. The tan graph, y is equals to tan theta. Remember that the period of the tan graph, the complete wave, is this piece. This piece is not complete, and this piece is not complete. The complete piece is this one here. So from 90 to 270, it makes 180 degrees. So the period of the tan graph is 180 degrees. Right? Now, to work out how am I going to draw that graph, I do the same thing as before. I just take the 180 degrees, I divide by a half. Okay? It's 180 degrees divided by half, so it means that the graph will go up to there, but what part? The complete wave will go up to there. So what we are doing, remember, we are stretching the graph. When we're stretching the graph, we are holding there, we are pulling. So if I'm pulling like this, where will this 90 be? I'm pulling, and I've got a scale factor of a half. It means that this thing will be pulled to 180. So the vertical asymptote now will be at 180 degrees. So our vertical asymptote, if I were to draw the vertical asymptote, it will be over there at 180 degrees. So that one becomes this. So if I'm pulling this, so this one gets out of the way, it gets out of this 360 degrees. Now, if I were to draw this, instead of this point being 45:1, now it would be at 90:1. So I'll have a point going there 1 to 9. So to 90:1, which means that my arm now will be going like this to there, and then I'll have another piece here that's starting like this one here. So I'll have a piece going like that. Okay, that's a half tan theta. So now we've looked at the horizontal stretch, and then also from the previous one we've looked at the compression, where we're compressing the function like pushing. Hold here, you push. Okay, so now if you can try on your own some of the examples from your Siavula textbook, chapter 5, and then you do the sine function, 5.5 sine function, exercise 5.21. 1, you do A and B. 5.6, the cosine function, exercise 5.25. 1, you do A and B. Then 5.7, the tangent function, exercise 5.29, you only do 1 and 2. I hope this helps. It should be easy for you to do. Done.